Hi, hello, yes. All right. Now, today we are going to be looking at a very critical topic or a very critical concept in chemistry. It starts with a question, and it is: where is hydrogen supposed to be in the periodic table? Is it group 1 or is it group 7? Is it the halogens, which are the group 7 elements, or the alkaline metals, which are the group 1 elements? Now, in order for us to classify this very well, we are going to be looking at the differences between hydrogen in group 1 and group 7, and also the similarities of hydrogen in group 1 and also group 7. But before we proceed, let's clear the fact that hydrogen is on group 1 in the periodic table. There is no doubt about that. But let's just brainstorm and see the differences. Should hydrogen be moved to group 7 or should it remain in group 1? Now let's find out with the differences or the points that I'm going to make. First of all, let's start with group 1. Now, what are the similarities of hydrogen in group 1? Number one similarity is that the valence electron. We find out that in group 1 elements, all elements there has one valence electron, one outermost electron, which hydrogen falls there. So hydrogen 1 has one valence electron and it shares the same similarities in that aspect. Second is the oxidation number. We know that the ordinary oxidation number of hydrogen is +1. Same with all other elements in group 1. Sodium and potassium and all other elements in group 1 has oxidation number of +1. So that's second differences. Number three similarities is the same orbital block. We know that when writing the orbital electronic configuration of the elements in group 1, they all have their last orbital to be s block. So hydrogen is classified in group 1 because it has same s block. It falls under the same s block as all other group 1 elements. So the last block in its orbital configuration is the s block. Same with all other group 1 elements. So that's number 3 similarities. Number 4 similarities is the formation of positive ion. We know that group 1 elements have the tendency of losing their valence electron in order to form a cation, right? Positively charged ion. Hydrogen also have that ability to lose its valence electron to form a cation, to form what we call proton. So when hydrogen loses its one and only valence electron, it forms a cation, H+, which is called proton. It also shares the same similarity with other group 1 elements, which also do the same thing, losing its valence electron to form a cation. Now the next one is combination with electronegative elements. Hydrogen also have the ability to combine with highly electronegative elements like oxygen, chlorine, fluorine, and the rest of them. Same with group 1 element like sodium. Sodium can react with highly electronegative elements like oxygen to form sodium oxide, like chlorine and fluorine to form sodium fluoride and sodium chloride. So the same with all other group 1 elements like potassium. They all have the ability to react with highly electronegative elements, right? So hydrogen also share that similarity. The next one is, which is the last one. All right, now lastly, the similarities between hydrogen and group 1 elements they are all reducing agents, right? Hydrogen is a reducing agent, and also all other group 1 elements are reducing agents. What are reducing agents? Reducing agents are those substances or those elements that has the ability to transfer or to give other elements electrons. So when a substance has the ability to transfer or to donate electron, that substance is called a reducing agent substance. So in summary, both hydrogen and group 1 elements are all reducing agents. Now the differences between hydrogen and group 1 element. Now this is where our main point is. What are the differences between hydrogen and other group 1 elements? Number one, the type of elements. We know that group 1 elements are full of metals, right? They are all metal, like the name sound, alkaline metal. But hydrogen is not a metal. In fact, at room temperature, hydrogen is a gas. So since hydrogen is a gas, it differs from group 1 element in that aspect. Number 2 is the type of bond formed. We know that hydrogen, when it goes into chemical combination, it forms covalent bonds. But all other group 1 elements like sodium, potassium, and all other ones, they form ionic bonds. So this is the major difference between hydrogen and all other group 1 elements. The type of bond they form differs. Hydrogen forms covalent bonds, while other group 1 elements form ionic bonds. The next one, number 3, is the formation of ions, right? Group 1 elements only form cations. They lose their valence electron to form positively charged ions, that cations, which hydrogen also do that. But hydrogen also have the ability to gain an electron in order to form hydride. So hydrogen differs in this particular aspect. Hydrogen has the ability to both form anion and cation, but all group 1 elements only have the ability to form cation, which is positively charged ion. The next one is electronegativity value. Hydrogen has a higher electronegativity value than all other group 1 elements. In fact, the electronegativity value of hydrogen is what? 2.1, but all other group 1 elements ranges from 1 to 0.7. You can see the wide range or the wide difference in electronegativity value. So this aspect is a difference between hydrogen and group 1 elements. Now the next one is reaction with water. We know that group 1 elements react vigorously, or they have the ability to react with water, but hydrogen doesn't react with water. In fact, it is insoluble in water. So this is a major difference between hydrogen and all other group 1 elements. In fact, when group 1 elements react with water, they produce hydrogen gas, but hydrogen don't even react with water. It is insoluble in what? In water. And lastly, the presence of acid and of base. We know that the main characteristic of an acid is the presence of hydrogen, right? Except for the Lewis acid, but all other ordinary acids has hydrogen in them. But when it comes to base, which is the opposite of an acid, base, we can find out that it has more of the group 1 the group 1 element, like sodium hydroxide. You can see sodium there, potassium hydroxide, and all other bases. So in summary, all other group 1 elements are found in bases. They are more in bases, while hydrogen are more dominant in what? In acids. Alright, now let's look at the similarities of hydrogen and the halogens. The names sound a bit similar, halogen and halogens, which are the 7 elements. Let's look at the similarities. Number 1 similarity is number of electrons needed to complete its outermost shell. We know that hydrogen, which has just 1 shell, goes for the duplet state, right? 2 electrons in the first shell, while all other elements that has more than 1 shell, like the halogen, they go for the octet state, which is 8 electrons in the outermost shell. Now you can see a similarity there. Hydrogen needs just 1 electron to complete its outermost shell, and the halogens also need just 1 electron to complete its outermost shell. So that is a major similarity between hydrogen and halogen. Number 2 similarity is the type of elements. We know in the periodic table we have metals and non-metals. Both halogens and hydrogen, they are all non-metals, right? So that's another similarity, is that hydrogen and halogens, which are the 7 elements, they are both non-metals. Both form diatomic molecule. Yes, hydrogen is a diatomic element and they form diatomic molecule. Also, halogen are also diatomic molecule. Diatomic means 2 atoms of a particular element to combine to exist as a molecule. So for hydrogen to exist, it needs 2 hydrogen, right? That's what we mean by diatomic. Same with the halogen. Halogen comes in pair. We have the chlorine pair, the bromine, and all other halogen. So they are all diatomic molecule. They come in pair. Another similarity is that forming of anion. Hydrogen also have the ability to form anion by doing what? By gaining 1 more electron. So halogens gain electron to form what? Anions. Also, hydrogen has the ability to gain electron to form anion, and that type of anion is called an hydride. When hydrogen accepts electron, it forms hydride H minus. And lastly, formation of covalent bonds. Yes, both hydrogens and halogen, when they go into chemical reaction, they always go as what? As equivalent elements, right? So when hydrogen form a bond, it forms covalent bonding. When halogens also form a bond, they also form covalent what? Bonding. Now let's look at their differences. Differences between group 7 elements, which are the halogens, and hydrogen. Number one difference is that number of valence electron. Valence electron simply means the outermost what? Electron. And you find out that there's a big difference there. The halogens have 7 valence electrons, while hydrogen has just 1 valence electron. So that's a big difference for hydrogens and the halogens there. And also reactivity. The reactivity of halogens there is far beyond the reactivity of what? Of hydrogen. So halogens, they are more reactive than the hydrogen. So this is a very wide difference between the halogens and the hydrogens. And also color. We know that hydrogen is a colorless gas, but halogens, all halogens which are non-metals, they have color, starting from the chlorine, which is yellowish color, down to what? The bromine and all other elements in group 7, the fluorine and the chlorine. So they form color, right? Some are yellowish, some are greenish, and the rest of them. So in summary, halogens form color, they are colored elements, but hydrogen is a colorless gas, right? They don't have color. And lastly, the type of orbital, the form. And like I said before, under the similarities between hydrogen and group 1 elements, I said hydrogen is an s-block element, meaning that if we write the orbital configuration of hydrogen, the last shell, the last orbital there is an s-block. But in the case of halogens, which are the group 7 elements, they are the p-block elements. They belong to the p-block. If you write the electronic configuration of the halogens, we find out that the last orbital there is p orbital, the p-block. So halogens are p-block orbitals, while the hydrogen are s-block orbitals. Now we have looked at the differences and the similarities between group 1 element and hydrogen. Can you tell me in the comment section, with all this I have said, or with all this we have discussed, can you tell me where exactly the hydrogen should be? Is it the group 1 element, which are the alkaline metals, or the group 7 elements? So drop it in the comment section. Don't forget to subscribe, follow this page, like, and make sure you drop a comment. Let me hear your own opinion. Where do you think hydrogen should fall? Is it the group 1 element or the group 7 element? Bye for now.